Hi guys, welcome to this next video. We're going to be looking today at simplifying algebraic expressions. And this one you want to be able to expand binomial expressions by the end of it. That's what we're sort of looking into. And by the end of this one anyway, you want to be able to simplify expressions using addition, subtraction, multiplication and division. Alright, pronumerals, coefficients and like terms, oh my! We're just going to have a quick look at some of the things that hopefully you've already seen before, so we'll sort of rush through. Right, so I just want you to remember that when we're looking at these things, so for starters, the entire thing here we've got here, this is called an expression. Okay, and you probably already know that. And expressions have inside just any combination of letters and numbers and any kind of operations, okay? But inside them we can have special things called terms. So this is a term, whoops, that's a term, and this here is a term. And a term is numbers and letters all kind of together, just with multiplication or division, okay? Now, also want you to remember that these numbers at the front are called coefficients, and the numbers themselves are called pronumerals. Sorry, the letters themselves are pronumerals. Now, let's have a look at some of our key ideas. So, just a quick reminder for you that multiplication and division symbols are not shown in your simplified algebraic expressions. And so, if we had 7 times x times z divided by y, that's equivalent to 7xz over y. So, nice and lazy mathematicians, that's the way we like to write it. Okay, now our common factors, they can also be cancelled when we have our algebraic fractions. I'm going to rewrite this one here for you in expanded form. So 18 is 2 times 9, x cubed is times x times x times x, and we've got a y, so times y in the end. 10 is 2 times 5 times x times y squared, so whoops, not y squared, times y. We can cancel our common factors, so the 2's go, the x's go, the y's go, and so we're left with 9x squared over 5y. Now, you don't have to go to all that trouble of expanding. You can just use your index laws, or you can just get a bit of intuitive about it as you do more algebra, but that's kind of what's going on in the background. Okay, like terms have exactly the same pronumeral factors. So if we had 4x squared y, that's the same, it's a like term with 72 yx squared. Okay, so the pronumeral factors means that they've got exactly the same letters where those letters have exactly the same powers. Remember, in multiplication you can switch it around with any order, and so it doesn't matter which order the letters themselves are in. Okay, and it's important you remember this because our like terms can be added and subtracted. So if you had 7x squared y plus 5x squared y, because they're both like terms, you're allowed to add them together. 7 and 5 is 12x squared y, okay? And that's how you go about that one. Alright, now however, any terms can be multiplied or divided. So if we had, let's look at our ones before, what we have there, 7x squared y, 5x squared y. So if I had my 7x squared y times 5x squared y, I'd be allowed to do that, definitely. Well, actually, I might change these to unlike terms real quick. So let's just 7x squared y times, I don't know, 5zy. Okay, so they're unlike terms, but we're allowed to multiply them together. So numbers first, 7 times 5 is 35. Our x squareds, no other x squareds to worry about, so you just put x squared, or no x's. Y times is another y here, so y squared. There's a z here, so the z just goes in. Okay, similar with division. If we had 4xy divided by 12 x squared y, we would rewrite that as you could rewrite as a fraction, or you can sort of go about it. So 4 divided by 12, so that's 1 over 3, common factor of 4, x and x squared, so I better write it, x squared and y over y, so it's probably a good idea to rewrite it. x over x squared, so that's going to give you just x on the bottom. The y's cancel out, so we're just left with 1 over 3x. Okay, so you've had a lot of experience with that, and hopefully that's just some nice revision for you. Okay, let's simplify the following expressions for some worked examples. Now you remember that back in the past I might have suggested to you, so as you go through, put different shapes around the different terms. So 3z, here's another z1, circles around my yx. This is also a like term with that, xy, because it doesn't matter with the order of the letters, remember? So let's do that. So 3z minus z is just 2z. And remember that these subtract signs belong to that term. It's really important. So now we have 5yx minus 6xy, so it's negative 1 yx. We're going to rewrite this, 2z. We don't need the 1 out the front, and we should really write it in alphabetical order. So 2z minus xy. Okay, another one here for you. So we got 6x cubed. We'll make that our ones with boxes around it. X squared. So here's important. Same letter, but the powers are different. So they're not like terms. So we might put circles around this one here. Plus 3x cubed. Let's get to box. Okay, 6x cubed plus 3x cubed gives us 9x cubed minus 5x squared. Now here's the important thing. Better put some equal signs here. Here's the important thing. You cannot go any further than this. You must stop when you're at that point. There's no more further simplification you can do there. When you can do some factorizing and things, let's not worry about that. You can, but just please don't try and shove them together. It's just not going to work. It's not going to happen. And try to resist the urge. Okay, some multiplication here. We got 3p times 2pq. So we're going to multiply our numbers together first. 3 times 2 is 6. We've got a p times p gives me p squared. No other thing on this one, so we just got letters that are left, just the q. Just smash them together with the multiplication. Alright, with the division, we've got our little fraction here. So the negative stays, and we've got 4 over 8. So that's 2 times 2, 2 times 4. We've got an x, y cubed, so y, and then x, y down the bottom. So let's do some cancelling. We've got some 2's that cancel here, x's and some y's. So we are left with... We got way more. I'm serious silly. This whole thing cancels. 2 times 2 is 4. And... Oh. And then the 4 cancels. Oh dear. Glad I picked that one up. Would have been a bit foolish. So we've got left. So we've got y, which is y squared over 2. And we're done. Okay. So... better not forget my negative, it stays there as well. So thanks for watching. Hopefully a lot of that was just revision for you, because we're going to really ramp it up in the next video and get into some nice and meaty algebra for you, which I'm sure you are just definitely looking forward to. Thank you so much for watching, and remember to come grab me at school if you have any questions. Thanks. Bye.